Welcome to Easy Elim Learning Simplified. My name is Ruth, and our topic for today is the structure of the atom and the periodic table that's from TUAC. Our subtopic will be balancing equations. So you start with simple equations, and then we'll go to some complex ones in the next lesson. So previously we talked about formation of chemical formulas. We were also able to calculate the number of atoms in each compound. That is going to be very helpful for this lesson. So make sure you go back and check that out. So for this lesson, you look at balancing simple equations, and then you get a chance to practice a few of them. So when you talk about chemical equations, this is actually a representation of a chemical reaction, and we represent it by chemical formulas and symbols. So when you look at a chemical equation, it needs to have correct formulas of the reactant on the left side. So if you were to look at a normal general chemical reaction, you can see we have reactants on the left side. So they need also to be having the correct formulas. And then we have also products on the right side. They also need to have the correct formulas as well. So the reactants and the products are usually separated by an arrow, as you can see. And then the state symbols are also usually written as subscripts. You're going to see that next later on. And then the number of atoms in the reactants will always be equal to the number of atoms in the product side. We say that there's no loss. The atoms are usually retained in both sides. So for example, in the reaction between copper, metal, and oxygen, so the word equations is what we discussed in Form 1. You can go and check that out. So copper and oxygen are the reactants. They react to form copper 2 oxide, which is a product. And then this is the chemical equation that is balanced. You can see the symbols in the reactant and the symbols in the product, and you can see the state symbols as well, and the coefficients of balancing. So we are going to start from this and end up with this. We'll see how we do that. So when you are balancing chemical equation, it can only be valid if it's balanced. So we have seen questions where you are told to write a chemical equation. The expectation that it always needs to be balanced. It has to be balanced. The number of atoms in the reactant will always be equal to the number of atoms in the product. This is because atoms are neither created nor are they destroyed. So we have to keep them equal in both sides. So what are the rules and guidelines in balancing chemical equations? So the first thing is to write the chemical equation in words, or we call it the word equation. This will make your work easier. So you can see, for example, our example question is copper metal reacts with oxygen. This equation is not complete, so we need to complete it. So it is copper metal plus oxygen gas to form copper oxide, and it is specifically copper 2 oxide. Although we also know that we have copper 1 oxide, but in this case, because it's the highest oxidation number, it will have the highest tendency of forming unless we are told otherwise. Next, write the correct formula of both reactants and products. Let's do that. So the chemical formula for copper metal is Cu. The chemical formula for oxygen gas is O2. Remember, it's gas. So it's just not O, it's O2 as well. And then the correct formula for the copper oxide, this one is what we just learned in the previous lesson. It becomes copper oxide. You can go back and see how we write copper 2 oxide to come up with this final formula. So next, we check whether the number of atoms in each element on the reactant side is equal to the ones on the product side. So let's write our equation again. So it's copper plus oxygen to form copper 2 oxide. So what I would like us to do is to separate the number of atoms. Remember we said that in the previous lesson. So copper we have one atom this side. So we are going to separate the reactants and the products and calculate the number of atoms this side. And then oxygen, you can see we have two. The reason why we have one for copper is because there's a one written here that is not true. You never put it in chemistry. Then copper this side, it's also one. As you can see, there's a one here, and oxygen is one. So if you check, you notice the number of copper atoms in both sides are equal, but the number of oxygen in the reactant is more than the number of oxygen in the product. So what do we do after that? Then after that, we balance. And when we are balanced, we use coefficient. What are the coefficients? These are the numbers we put in front of the compounds. So for example, let's look at our example. So we said it's copper plus oxygen gas to form copper oxide. We separated this. We said copper we have one, oxygen two, copper we have one, and oxygen two. So our purpose is to balance the oxygen. Our balancing, when we balance the oxygen, the copper might be affected or not. So let's check that out. So we have two atoms of oxygen on the reactant and two on the product. So how we have one on the product. How do we make this one to become two? So what we'll do, we'll multiply by two. This two is the coefficient one. And the moment you multiply these two here, you need to put it where oxygen is on the equation. This oxygen atom is on the copper oxide. It's not on its own, it's in a compound. So these two that we have multiplied with must be placed on front or in front of the compound. So you put that two here, not on just the oxygen, but the whole compound. So you see our oxidants are now okay. But you notice the moment we put this coefficient here, it's going to affect the number of atoms in copper. So you see, initially we had one copper atom, but if we put these two here, it becomes a coefficient. It means it becomes a multiple for all the atoms in the compound. So we have also to multiply this with 2 because you can see it is in front. It's like it's an invisible bracket. So we have two copper atoms now, which affects the initial that we had, the initial calculation that we had. So this affects this copper. So we need to balance it as well. So to make this copper in the reactant also to be 2, we have to multiply by 2. Where do we put this coefficient 2 we have just multiplied? We put it in front of the copper. All right, and so you will check back again and ensure it's all balanced. If it's not balanced, then you repeat the process until it becomes balanced. Some other cases, you need to repeat this process again and again. So the next thing we do after we have balanced our equation is to ensure that we have the physical state or the state symbols. It needs to be correct. So there are different types of state symbols. We have solid, which denotes with an S. We have liquid, which denotes with a small l, aqueous, which denotes in AQ. And for aqueous solution, this is the substances that are dissolved in water. So almost all substances in chemistry that are in solution states are usually aqueous. But there are some unique liquids we have like water and some concentrated acids. And also we have like hydrogen peroxide is also liquid state. Whenever a solution is in liquid state, you will always be told when you are being explained on what the reaction is occurring. And then gaseous state is denoted as G. So let's go back to our equation and so that we can make it correct, fully correct. So what you notice is we had a 2 in front of copper, we put the solid, and oxygen, we said it's a gas, and the product is a solid, which we put an S. So this becomes our balanced chemical equation. So let's do a few examples so that you can see what I just did there. And we will put everything and come up with a final example. So we'll start with this. When fluorine gas reacts with calcium metal, calcium fluoride powder is created. So this is the question we're looking at. So let's look at the reactants. So the reactant is fluorine gas reacting with calcium metal, and then it forms calcium fluoride. We said we always start with the cation or the metal. In this case, we start with calcium, so it's calcium reacts with fluorine gas to form calcium fluoride powder. So this is a word equation. You can start with the word equation, but later on as you get used to these equations, you don't have to. So the symbol for calcium becomes Ca. Symbol for fluorine gas is F, but it's a gas, so it's diatomic in nature. You learn that in the next topic. And then the formula of calcium fluoride, which we did in the previous lesson, we did this lesson, you can go and check it out. It becomes CaF2. This is capital F. So this is the equation. The next thing that we do, we calculate the number of atoms in the reactant and the product so that we can balance it out. So let's do the calculation together. So calcium, we have one atom as you can see. Fluorine, we have two atoms as you can see, there are two. And then in the product, calcium, we have one atom as you can see from here. Fluorine, we have two atoms as you can see. So you can see the calcium are 1, 1, fluorine they are 2, 2. So this compound, the atoms in the reactant are equal to the atoms in the product side. So we come and put our final answer here, calcium plus fluorine to form calcium fluoride. But remember, this equation is not complete until it has the state symbols. So we input the state symbols. So for calcium, we have been told it's calcium metal. Metals are in solid state, apart from mercury. So calcium will be solid. And then fluorine, we have already been told it's in gaseous state, so we put the G. And then calcium fluoride, we have been told it's a powder, so that is in solid state. So this is our final equation. So it becomes calcium solid, react with fluorine gas to form calcium fluoride, which is solid in state. This becomes our final equation. Let's do another example. Sodium combines with chlorine gas to form sodium chloride. So the word equation will be sodium reacts with chlorine gas to form sodium chloride. So let's convert this word equation into chemical formulas. So the chemical formula for sodium becomes Na. Chemical formula for chlorine gas becomes Cl, but it's gas and it's diatomic in nature. It becomes Cl2. And then the chemical formula for sodium chloride becomes NaCl. Next, we calculate the number of atoms in each side, the reactant and the products. So sodiums, we have one. Chlorine, we have two atoms. This side, we have one atom of sodium and one atom of chlorine. So as you can see, the sodiums in both reactants and products are equal, but our chlorines are not equal. So we have to balance the chlorine. So the first thing we do, we go to the product where we have one chlorine. We have to make it 2. How do we make our 1 to be 2? We multiply by 2. The moment we do this multiplication, the 2 that we have just multiplied becomes a coefficient. We are going to place this 2 on the compound where chlorine belongs to. And chlorine belongs to sodium chloride. So we do not put these 2 on only chlorine. We place in the whole compound. So we will put these 2 in front of sodium chloride. But the moment we do this, it does affect the amount of sodium atoms in this compound. We add a 1 here initially, but this 2 multiplies with 1, so the total sodium atoms we have now are 2. So we need to balance the other side as well, which was initially 1. So to make the 1 sodium on the reactants to be 2, we have also to multiply by 2. So this also becomes a coefficient which we place where the compound of sodium is. And sodium is on its own, so we just put a 2 in front. And this balances out the whole equation. So you can see we have 2 sodiums in the reactant and 2 chloride ions in the reactant, 2 sodium atoms in the product and 2 chloride atoms in the product. So it is balanced. But remember, our equation is not fully balanced. We need to put the state symbols. So it becomes sodium is solid in nature, it's a metal, plus chlorine, we have already been told it's gaseous state, to form sodium chloride, and it's 2 sodium chloride, and this is solid in nature. So this becomes our balanced equation. Let's do one more example. Magnesium catches fire in the presence of oxygen to form magnesium oxide. So we are reacting magnesium with oxygen gas in the air to form magnesium oxide. So this is a word equation. Next, we convert this word equation into a chemical equation. So the symbol for magnesium is Mg, symbol for oxygen gas is O2, symbol for magnesium oxide is MgO. Next, we look at the number of atoms in each side. So magnesium, we have a total of 1 atom on the reactant, and oxygen, we have a total of 2 atoms on the reactant. On the product, we have a total of 1 atom in the reactant for magnesium and 1 atom in the product of oxygen. You can see 1, 1 and 1, 2. So our magnesiums are okay, but our oxygen atoms are not equal. So we have to make them equal. So to do so, we have to multiply with a coefficient of 2 to give us 2 atoms. But in the moment we multiply by 2, we need to put this coefficient in front of where the oxygen atom belongs to. This oxygen atom is in magnesium compound. It's not on its own. So we have to put the 2 in front of the compound. So if the moment we put 2 in front of magnesium oxide, it affects the number of magnesium atoms also in the compound. So this magnesium becomes 2 as well. So this makes us to also have to balance now the number of magnesium atoms in the reactant, which is 1. So to make it 2, we multiply by 2. These 2 that we have multiplied with, we have to put it in front of where the magnesium atom belongs to. And in this case, it's on its own. It's a compound on its own. So you put a 2 in front of magnesium. And this balances the equation. So our final equation becomes 2 magnesium, and it is solid in state, it's a metal, plus oxygen gas to form 2 molecules of magnesium oxide, which is solid. This is our equation that is balanced with correct state symbols. Finally, the last question to work on, potassium oxide reacts with water to form potassium hydroxide. So you can see you have already been written the word equation. So our work will be to convert this word equation into a chemical equation and balance it. So potassium oxide is written like this. Go back and check how we got this from the previous video. Plus water is written like this. to form potassium hydroxide. So potassium hydroxide is written like this. Also check out the previous videos on the polyatomic ions and monoatomic ions. So next, we calculate the number of atoms in each side, that is the reactant and the product. So potassium, we have 2 atoms, you can see. For oxygen, you need to be careful. It's 1 atom here, so I like to separate the 2. So we have 1 atom on the potassium oxide plus 1 atom on the water, which gives us a total of 2 atoms. Then hydrogen, we have 2 atoms, as you can see in the water. In the product, we have 1 potassium atom, oxygen is 1, and hydrogen is 1. So you'll notice the reactants all are in 2s and the products are in 1. So we need to do some balancing. So when we balance, now we need to balance everything else. So we can start balancing with the oxygen, we can start with the hydrogen. I always like to start with the oxygen. So to balance the oxygen out, I need to multiply this by 2. The moment I multiply by 2, this coefficient I've introduced, I need to put it where oxygen belongs to. And this oxide is in the potassium hydroxide compound. It's not on its own. So this 2 needs to come in front. So it forms 2. So the moment this 2 comes in front of potassium hydroxide, it affects the whole compound. So now our potassium becomes 2 and our hydrogen also becomes 2. This balances out the whole equation. So you can see we have 2 potassium both sides, 2 oxygen atoms both sides, and 2 hydrogen atoms both sides. So next we finish the equation by putting the state symbols. So potassium oxide, which is a solid, it reacts with water, which is a liquid, to form potassium hydroxide solution. It's usually a solution. We did this in Form 1 when we were talking about reaction of metal oxide in water. So this is the final balanced equation. This brings us to the end. So in the next lesson, we are going to look at more complex equations and how we can balance them out. See you then.